Colin Renouf. He is Chief Information Security Officer at Helios. And Colin is going to talk to us about risks, security, and regulations for AI and machine learning, a big topic in the EU, where I'm originally from. I'm Dutch, by the way. If I'm speaking double Dutch, you don't know what I'm talking about, just yell out. Don't wait till the end. just stop me. Colin's been in the industry for 40 plus years. You wouldn't be able to understand how that's even possible, but yes.
I'm old.
Yeah, you're experienced.
Really old.
You're mature and experienced. You've been loaned, I love this word, you've been loaned to vendors like IBM and Microsoft to assist in research on hardware and software kind of challenges. And also you're a government advisor on cyber AI, critical infrastructure, and studied AI and machine learning at the uni in the 1970s.
Yeah.
And then redid it in 2024.
So this is the one of you, the fundamentals of ChatGPT 1975.
Exactly. So good moment to hand over.
Okay, thank you.
Enjoy Colin's session, everyone, and give it up for Colin. Thanks.
Okay, good morning, everybody. Good morning, Sydney. Come on, let's have some... Right, good. Now, and by the way, I'd like to say thank you to Hamish that's down here, because a lot of the stuff that we do in cyber security wouldn't happen if it hadn't been this man stirring up trouble in a good way. So, thank you, Hamish. Okay, now, what I'm going to talk to you about is AI, the hype. And it is actually new from the way that we have to protect things. It's not just like, I've got some code, I need to protect it. I've got some infrastructure, I need to protect it. With AI, it's all about the data. Now, as the people at the back will know, I have a slide deck that I was using for the Tizen for Home Affairs. And originally I had a load of slides right at the front with and these are the regulations. One thing, there are changes about twice a day at the moment in different sectors. So I've deleted all that and I've gone back to first principles because we are actually having to respond really, really quickly. So what are we going to talk about? Securing AI, large language models. Why do you want to listen to me? As you heard, I've been doing this 40 years. Nothing new. I did have a version of this slide deck that I used in another conference where on the bit where this is ChatGPT, I used the original picture from a textbook in 1975 with the background all a little bit yellow in a photograph, and somebody saying, it says 1975, but I've got the date wrong up there. And why didn't you use cut and paste? We didn't have that in those days. So been doing this a long time. Okay, what we're going to cover. Large language models, stupid name. This week's large will be next week's small. So let's just call them language models or just models. I've also changed the slides around to talk about the message, what I want people to get from this. Because I do know that some people, when I go on to this is what goes on under the covers, you're likely to think, oh, what's he talking about? So talk about the problems, talk about why we have to react differently. And then I'll go through how it all works. Because one of the things I found in this, we can't secure stuff if we don't know how it works. And there is an awful lot of nonsense out there. So there's a question. You've experienced this, a few of you, so you can go to sleep now. Always ask this question. Who here is an expert in the fundamentals of AI? Okay, I'm going to ask the same question in a different way. Who went to school? You all did the fundamentals at school when you were a teenager. Everybody remember doing scatter diagrams, the dots all over the screen where you draw a line through it? What? You all remember that? That is the fundamentals of machine learning. Now, machine learning, basically it's, right, I've got all these dots and it's like a probability of being close to a particular dot. So you draw a line through it. Now, human, might take me a minute to draw a line through it, 2 dimensions. The laptop that's just there can do it 50 trillion times a second. And with large language models in 192 billion dimensions, a little bit faster than I can. All we have is faster technology, more data. Now, so you already understand it. So when people talk about weights, it's the slope of the line. It's really not that complicated. Now, how does it learn from that? It literally goes back, does it a few times, has a guess at a line, goes back and says, oh, I can get a little bit closer if to all these dots if I change the slope of the line there. That's actually what the learning is. It's changing the slope of the lines. It's honestly not complicated. And all the vendors that do, well, I don't think you'll understand this. You all did it at school. So I thought I'd start with the message because originally I had slides about, and the regulations are this, can't keep up. So the aim of this session is to emphasize that AI systems, and I'll explain what I mean in a second, I have to worry about the data, not the code, the data. Now, here's a stat. This is public information. Out of 500 AI projects, and this is an industry stat, only 2 are considered successful. So that's a 1 in 250 success rate. And when you actually find out why that is, it's actually not a technology issue. It's we didn't know what data we were going to use for planning, or I didn't really have an objective for what I wanted to get from AI, but AI is cool, which I hear a lot. Or it's I didn't have a strategy. I didn't have the right tool for my domain. I didn't have a strategy for what I wanted to get out of it. So I'm going to explain how all of this happened, how we got there, and let's try and cut out the hype, because give some context to the hype. As a CISO, at the start of the year, I would see around 5 new AI tools a day in the healthcare industry that I'd have to evaluate. One day, 2 weeks ago, it hit 160 new AI tools, new a day, and most of them, absolute waste of time. No need for them. So I'll start with explaining what we're doing with regulations and why I've deleted half the slides in this, except the Tizen version that I'll use online. I'll leave them in there. Now, we have guardrails to protect the use of AI. Now, I'll talk about what AI is in this context in a minute. But Australia has guardrails that become mandatory for high-risk systems. What's a high-risk system? Can it do bad things to a person, an organisation, to society as a whole? Now, for that, I probably need domain-specific models and domain-specific tools. I also need to have some expertise. I need to have a human in the loop. These are all regulated environments. What's a regulated environment? Well, actually, most of us are. We're in OT, we're in CI, chances are we're regulated. Now, this is the biggest change to this slide deck since the last time I did it. ISO, there's a typo there, ISO 42001. That is the ISO standard, and most of the new regulations that are coming out from Home Affairs, DFAT, in healthcare from the TGA, all of them actually derive from the guardrails, which come from this ISO standard and from this. So it's a lot easier to say, all these new regulations are coming in, follow this standard. It's actually quite readable. There's 38 controls for just looking after your data. There are auditors. I think there's 5 of us now in Australia. It's going up every few days. Who can explain all this stuff. More than happy to talk to anybody about it. But what am I doing? I'm protecting the data so it doesn't do bad things. So, right. Mandatory guardrails. What's a high-risk system? Risk of adverse impacts to an individual, physical, mental health, the law, the economy as a whole, and if any of those are true, it's a high-risk system. And that's going to be the case in most regulated environments. Don't worry, we'll get to the really cool stuff in a minute. And then what do? If I've got a high-risk system, I establish and implement an accountability process. Why? Well, you can't just do AI. Someone has to be responsible for it. Now, let's say I'm in a hospital and I've got a new surgeon who goes, hey, AI is cool. I've got a robot. It's got AI, it's really good. Do I want him in the middle of an operation to, well, the AI is doing that, I don't know what it's doing, and walk away? No. So you need a human in the loop. Someone has to be responsible for these tools. Got to have a risk management process because AI is going to get things wrong. Have you heard about hallucinations? And I'll explain some very specific, dangerous hallucinations, which is where these regulations come from, and how we prove it in a minute. I've got to protect them, and that's not just the infrastructure. I'm protecting the data. Test them. I've got to have humans in the loop, And if I'm using AI to affect someone, let's say it's a patient, I've got to ask them if I can use their data. And I've got to be transparent. When something goes wrong, I can't just do, well, I'm not going to tell anybody about that. I've got to say how it works. Now, you can have AI systems that will explain all the things they're doing. It's something that we call chain of thought processing. So lots and lots of text. We'll get to pictures in a minute. So if I'm going to introduce a new tool, what do I want to do? I want to find out what data it's going to use. I want to find out where it's going to be stored. I want to know how it's going to be updated. If it's in a cloud environment, where is that cloud? You might be surprised to learn that quite a lot of the AI technologies that we had until recently, you'd look and say, this is all in Australia, but because of the very expensive hardware, it was somewhere like Singapore or the US. Now, I see an awful lot of AI tools every single day where people say, oh, well, it was very cool. And, the company, they've got an office in Australia copying data that should not leave this country to the US, Singapore, Europe, kind of hoping not so much Russia. You all heard of DeepSeek. DeepSeek is a family of tools from Alibaba called Qwen. So again, where does that store stuff? China. So I've got to trust my data, know where it is, and data in and data out. I've also got to monitor it. But right at the very top red line there is why I've put this right at the start. There's a very, very important term in there. AI systems are non-deterministic. Not my code. If I execute the same code with the same data, every single time I'll get the same response. It's not true with AI. AI, I can ask the same questions with the same data and get a different response each time. So it's non-deterministic, and it's the data that influences decisions, but under the covers, there can be almost none or a lot of randomization. But the chance of you getting the same answer each time, very low. And that is really, really important in critical infrastructure. So what am I going to do? It's all about the data. To use the data without negative impacts, I've got to make sure the data's clean. Now, one of the things, and it took me a while to actually get this into my head, maybe I'm just stupid, but everybody does, right, I've asked this tool to look at the internet. What's the most common thing on the internet? HTML tags. Tags in PDF records. Do I really want an AI tool to think that's the most important thing to me? No. So you've got to clean the data. There's duplicates. And one of the most important things is most of the tools that people use for their everyday use, they were trained on the internet. Grok was trained on Twitter. A lot of the stuff was trained on Wikipedia. Now, you can actually say, learn the language, don't go any further. That's a good approach. And then you train stuff in domain-specific stuff. So in healthcare, we have healthcare domains. We have a tool called MedGemma from Google, for example. But I can prove that no matter how I set things up, I can't stop something like ChatGPT, which is a good tool, or Copilot, the native ones that people get off the shelf. I can prove that quite a lot of the time, if I ask it to do a diagnosis, it's going to find HouseMD, ER, not the doctor or the Lancet or something that actually is qualified. I really don't want that. I want the tools to actually use the data that's relevant to that domain. And this is where the regulations are coming into it. So what's AI all about? AI all about? It's about statistics. So I mentioned the AI failures. 500 AI projects, only 2 successful. Why? Lack of cleaning and tidying of the data, so you've got a proper data supply chain. Lack of strategic alignment, choosing the wrong tool. And the biggest risk for most of us at the moment, data exfiltration. The number of times that I see people, oh, I just use Copilot to process this. Okay, Copilot, you can usually control that within your Azure tenancy. I just used Claude and ChatGPT. Do you know the pop-up that said that it was copying data outside the country? Yeah, I never read those. we have this thing called the law, and it's a really good idea that people follow it. So what do? Learn about AI, get the right skills, choose the right model, tools and infrastructure, and from the start, plan what you want it to do. Don't just do AI is cool, which a lot of people do. Make sure the data that you need is available and maintained. So AI tools have a thing called drift, which means over a period of time, because society moves on, the learning may not be kept up to date. If you look carefully at things like the last Copilot, I haven't checked the current one, or the last ChatGPT, and you ask it about history, it only knew up to 2022. It takes that time, that length of time to actually train them to learn about things. So if I ask it, please tell me what happened in the last couple of years, it doesn't know. So what does it do? It makes it up. It's called a hallucination. And you can ask it not to do that. So what do I need to do? I've got to protect the systems, ensure the data is handled properly in accord with regulations and what I'm trying to do. And when training it, stop it copying the data overseas. Wait, look at those prompts. Have a policy. Now, in the policies, say you want people to be able to use AI tools, it's quite useful, but give a background as to what tools are useful, explain the risks, and protect the confidentiality. Now to the fun stuff. This is how it all works. So what do I mean by AI? As I said, I took these slides out of order because a lot of people, I thought, probably don't want to see the pictures. So AI, the term, is actually anything that is exhibiting intelligence in a machine. And that is the term as it was in 1975. And actually before that, 1942, I think the first system declared as AI came out. However, the usage of the term tends to be that people now, when you mention AI, they think of language models like ChatGPT and things. So now we separate them out. Machine learning is basically statistics-based stuff where I give a machine a load of data, execute some algorithms against it, and it learns from the data and comes up with a numeric answer or something like that. Language models, a little bit different. They actually work with language. But believe it or not, they're the same technologies under the covers. Deep learning, layers. So let's have that in a handy picture form. You can do it. Hey. Now, how does it all work? It's actually not that complicated. So, we'll talk about transformers. Transformers is probably what started the revolution. So GPT actually stands for Generative Processing Transformers, I think it is. Now, the way it works is I have a piece of text. So I put a sentence in, and there's something called a tokenizer, goes through and breaks that sentence into words or stems of words. So famous, which I've used in there, actually gets broken down into fam-us, because I could have fame, famous, all of which are variations of the same core meaning. So that's called tokenization. Literally break the sentence down, and then it's turned into embeddings. What are embeddings? Literally, they are numeric representations. So tokens have an ID, a number, and once it's broken them down, but literally they represent actual words. Embeddings represent the relationships for words. So you have a thing called an embedding layer that literally goes through and says, I know that dog is an animal, so it's kind of related to a cat, and a kitten is a type of cat, and the embeddings literally get represented like that. And that's where the learning comes in, because you might think, well, how on earth does that work? Literally, these tools go through millions and millions and millions of documents, and they do something called term frequency, inverse document frequency. Big name, but when you explain it, it's actually really simple. This document uses the word dog a lot. It's from a veterinary journal. So clearly, this is about something called a dog. It then compares it with other documents and says, but I don't see dog in every other document on the internet. So dog must be a unique concept to that. And then how does it learn noise words like is, the? It does, like, I see the an A, an is in every document, they can't be important. I'll ignore them. So that's what these embedding things are. So when they came up with the technology, that technology has been around since the 70s. And they had these neural networks, you'll see them off to the right-hand side, and they would literally go through and look at how often words and things would occur. And that we call weights, is statistics. I know that I've seen the word dog in this document 57 times. So in this document, it's important. That's a weight. That's what the neural network's picking up. And it literally sets up a pathway between individual nodes that are just algorithms that say this bit is important. So that's how it actually comes up with the weights and how it learns its statistics. What they then came up with is these things called encoders and decoders, and that is the fundamental stuff that's in all the technologies that we know and love. But there's a slight modification to it, which best implementation that I've seen anywhere in the world is New South Wales government. I'll explain why in a minute. They do it right. I need to go through, and all these words, they have context. So in context, it's a case of, I'll show you on the next slide. Attention. I know that in this document, William and Shakespeare, don't see them that often, must be a name. So there's a thing called entity identification. But what it does, it goes and says, these words I see used together in a flow, and there's like, think of it like separate threads that go through and look at, I see this word before this one, and they're called heads of attention. So it knows the relationship between words in a sentence. And that's how it actually fakes looking intelligent, because it knows the order the words tend to get used in together. And that's attention. So when you're processing in these encoders, the encoders look at this is all the data I've got in. So I know the relationships there. When I'm generating stuff, the decoders are, these are the sentences that I want to put out. It's actually not that complex. So encoders, I want to check all the data that's coming in. I might want to classify it and say this is spam. This picture here, you've probably all got spam filters in your organizations. That's how they work. Okay, not the color scheme, but the actual code underneath it, that's exactly how they work. Anyone using ChatGPT or want to go and generate a picture? That's how that works now. They tend to not look so much at the input data. They're now customized to, hey, this guy wants to do a picture of I don't know, Donald Trump in a spacesuit. I know, I'll customize it, so that's where I'll put my effort. But the architecture's the same. GPT-5 and the latest lot of tools from the big vendors, and if you look at Copilot, go to the top right-hand corner, and you've actually got Microsoft who own a lot of OpenAI, and therefore own most of ChatGPT as well. There's a little blue button saying, try GPT-5. So you can't decide which tool to use? Use both. Click the blue button. There you go. So this is the way that AI is moving to for safety. And this is why it's important to ask these questions from a regulatory perspective. And best implementation I've seen anywhere in the world is New South Wales government. It's something called the mixture of experts architecture. What does it mean? I'm going to have multiple of these language models, and then I'm going to have a custom one at the end to do I think that one's wrong, or we shouldn't have used that one for that. So I might have a model that's sitting there, this is my one that's an expert in everything to do with medical history, or this is my expert in languages, or this does good pictures. I mentioned the New South Wales government one. Those of you that interact with the most current build is I think it's the Education Department of New South Wales. It knows more languages than pretty much anything on earth. They've sold some of the stuff back to Microsoft quietly, and we should be proud as Aussies. It taught itself with this, a separate model that maintains and watches all the others. They have one learning languages, one that understands things that people have at different ages, so to help kids learn and things like that. It actually learned how to swear and translate bad language in different and curse in so many different languages as an accident of the one in the New South Wales government. It learned so much bad language that they've given it back to Microsoft as you can now use this, so you can take curse words out of everything. Or if you want to swear, well, I now know how to curse in 400 different languages. But it's this supervisor one that's actually doing all the work. This is the way the industries are going for domain-specific stuff. So you have a gating function that sits there and looks at, actually, that doesn't seem very safe. This is brilliant, and it wasn't invented here, but best implementation here in Australia. Now, I mentioned about it actually learning. Would you believe that you can actually tell these tools, make stuff up, lie to me, or you could tell me, oh, I'd rather you didn't lie here. You could just literally go and put these in a prompt and say, top K, find the 3 most probable words in here that would fit in this sentence, top K equals 3. Or sum the probabilities, anything over this value. So again, it's statistics. Temperature. Temperature equals 1 means random. Just make stuff up. Don't worry if it's valid, make stuff up. People don't realise that for safety, you actually have to do this. So this is an actual test, and we got it to generate pictures out the side of it. Give me the next word. What was the man leaning against? And most common thing it found in there, wall, fence, car. But we could actually get it to come up with a wet goat. Because it's a case of you can get it just to make stuff up. People don't realise that this stuff goes on under the covers. So setting these parameters when you install this stuff is actually kind of important in critical infrastructure. Now, I said I would prove something. It was actually quite hard to get the slide generated, but we asked some questions, and I can do this on any of the vendors' ones, and the numbers come out slightly differently. But I asked some questions about diagnosing a hematoma, and then you can ask it, give what's called a chain of thought, and to show it's working. Please tell me where you got this diagnosis from. Did you use the Lancet, like I asked in the question? No, HouseMD. I went back and I found a script. There was this episode when House was following Cuddy back to our home and doing something, and he mentioned a hematoma. He actually used that. That is disturbing. Or the other one on the right-hand side, not so much disturbing, but this is one that we've actually written malware to prove how easy it is to break these things. We asked, is a kitten a type of cat? And we can now swap it and say, no, it's a type of dog. Again, you can write malware to change the data, to change the decisions, and show that an aeroplane, kitten is not the same thing. So, how do I get around this? I protect the data. I pre-train these models, and believe it or not, the AI vendors mostly work together. They've divvied up the work for safety because they know that this is a generational change and the world's got to do this right, otherwise people die. They're working together. So this is the way that they're saying that we have to do things, and it makes sense. I need to take some of the open source tools. I can play with them. I can get Microsoft underneath Copilot. It's a bit of ChatGPT, GPT-4o, I think it is, plus something called Phi. That's the open source one. Anyone can play with it, learn it, use it, and extend it. You can teach it to the point where it learns language, and then you give it domain-specific information to work with. So in healthcare, I give it the Lancet, I give it medical records. In energy, I give it all of the safety stuff that I'm going to have as criteria. So it has to come and understand it. So what's it all about? It's about weights and setting restrictions on data and responses. So learn the language, nothing more, because I do not want stuff quoting from HouseMD if I'm in surgery. How do I do that? These are I've gone through this. These are all the things that are what we call an MLOps pipeline that you have to do to make sure your data is clean and to protect it. I've got to look for PII. Why? Because I really don't want ChatGPT sharing my Medicare number with the rest of the world. Well, deduplication. Why? Because a lot of the time, if I took Wikipedia, a lot of them have references to the same thing. I don't want these will be shared with everybody afterwards. Augmentation. Sometimes I might use a particular phrase, let's say ASD. I'm not going to change that to be Australian Signals Directorate. Yeah, so that's a type of augmentation. Sometimes if I've got pictures of someone's heart, I'm not going to change the colour of the background to bring out certain qualities. That's augmentation. I want to remove junk. So HTML tags, do I want it to learn those? No, thank you. Quality filtering, cleaning, extract actual text, identify the language. Do I really want, if I'm going to use something here in Australia, do I want it quoting Russian? Probably not, or unless I'm a spook. Any Russian spies in the room? Okay, just asking. Yeah, Strasbourg check. Perplexity. Okay, we won't go into that. That's an AI specific term. But again, all of these things, I clean the data. I clean it before I use it. I clean it for the domain. So healthcare domain. I tune it once it's in use, and I just do it over and over again, no matter what sources I use for the data. I pre-process it. I also tell it only answer if you're sure of where you've got the data from. So I mentioned hallucinations. Go through and use something called chain of thought. Explain to me how you arrived at this. The number of times people think, well, I just used AI. Great, ask the question. Ask the tool, explain it to you, and it will. So these are the things that we tend to do. Good AI, there's some really good training courses that are mostly funded by the government. I think it's $260 here in New South Wales, written by Macquarie, UTS, but it's available across the country. Each state's got them. Here it's called IAT, but $260 courses taught by actual experts from the unis at night school. And they will they'll teach you about what's called one-shot, two-shot, template learning, all these different things. But basically, ask any of these tools. You are an expert, you're a university professor in physics. Tell it the context of what you want your answers in. Give it instructions for what you want to do. Summarize these, be specific. Format, if you want a Word document, say, I want this as a Word document. Tell it the target audience. The number of times I now see, explain this like I'm a 5-year-old. That's actually a really good prompt to use, unless you're actually a 5-year-old, in which case probably something more advanced. Tone, say it should be professional or humorous. You can actually get them to tell jokes. Sometimes they're even funny. And always tell it where to get the data, and if it's wrong, tell it. Use the phrase, explain. So, chain of thought processing, explain to me how you did this. Now, this is just an example of something that anyone can download called Llama, running one of the open source ones underneath Copilot, asking questions. Literally, download, play, you can't do any damage. And on the next slide, you can all have this. I'm literally showing the working for what goes on under the covers. Your development tool, a browser. Google do a site for doing it, so do Microsoft. So Google Colab, I create this thing called a Jupyter Notebook in a browser, and I enter a few commands which are in here, and it will do it. So, where are we? Storing the data, just finish up now. Storing the data, it's non-deterministic. Make sure I know what's happening with the data. Stop anyone from tampering with it. The number of times I see, well, in fact, all of the models from all of the vendors, when they work locally on edge devices, security, 0. Anyone can change the stuff that's got admin rights on the machine, and elsewhere in here, I will show where things are stored and even how to write malware. Why am I telling people how to write malware to attack an AI tool? Because I want you all to realise that really simple things like locking down the model storage So someone can't write malware, protects against all of them being hacked like this. It's all about all the things you know and love, but to protect the data, to make it so the tools you use make the right decisions. So in here, I've given examples for review, and also I took out the code for the malware, because Hamish would tell me off, I'm sure. But I can explain to people how to write it. Why would I do that? Because I want you all to realise it's just about protecting this data. Agentic AI, multiple tools working together. It really isn't complicated. You all know how to do this. So, what did we learn in here? We learned it's about protecting the data. If I've got multiple AI tools, I want to protect how they talk to each other. What am I protecting? The data. How do I do it? Identity management and access control. It really isn't that hard. You all know how to do it. I protect my infrastructure. I protect who has access to stuff. Edge devices. Literally, I do what I already know, but this time I'm protecting the data, not the code. And that is what I would like to leave you with. These are the layers. And when we started, we looked how to evaluate an AI system, how LLMs work, how we interact with them, how the data's stored, and why are we doing it? We protect the data to stop it killing someone. And there is a court case in the US where advice from an AI tool did cause a child to kill himself. So it can result in death, and it's not just I've given medical advice that's wrong. It's about get the data wrong, people will die. So thank you.